guys, please get this information just in case you didn't get it from this morning when we went through it today in class. Just go through some key information. You get to use your foldable. We want to define a dilation as an enlargement using in terms of the scale factor. A couple things. That's the cursive K, represents the scale factor. It's a number. And basically it's your number that you're multiplying by to every term, every x and y variable value. Oh, excuse me. All right, so if I want to just show it in terms of the scale factor, we would say for it to be enlargement, it has to be greater than 1, okay? So basically you need to know that for it to get bigger, your scale factor needs to be greater than 1. Now, I think on your foldable, I think we have like the letter A is greater than 1. Doesn't matter. It's just basically that's representing a variable, and the variable represents a number. And if our number is, or if our variable is A, then we can say A is greater than 1. But universally, usually it is K. So define a dilation reduction using in terms of scale factor. For it to be a reduction, in terms of the scale factor, it would have to be between 0 and 1. So basically our scale factor, the number we're multiplying by, is between, and this is my abbreviation for between 0 and 1. And remember, our scale factor is the number you're multiplying. To x and y. Okay, number we're multiplying for x and y. Alright, now we talked about this since the scale factor 3/4. If you know 3/4 is between 0 and 1. So this is why this is a reduction. Some of you already have this, so you can fast forward through the video if you, if you already have this material. And then we had, this was an enlargement. And the reason why is 4/3 is greater than 1. So whenever it's greater than 1, it's an enlargement. Alright, then we talked about, make sure we know specifically what you're going to be responsible for on the test. So when you read the information, underline key information, we need to know the points. Transformed by a dilation, dilation's key. That means I'm multiplying. D2 tells me what type of dilation. You're going to graph the pre-image and image. We're going to identify the new coordinates. That's important too. So remember, D is for a dilation. D2, if I see D2, basically I have a dilation with a scale factor of 2. So that tells me what I'm going to multiply each coordinate by. It's going to be 2. So we did this. Here's what I'm going to check for on the test. 1, I'll check you have the right coordinates. So we had -4, 4. We had 2, 6. And we had 2, -2. So I'll check all that. And then I'm going to check for your pre-image and image. So I'm going to check that you have graphed the original figure and you have graphed the new figure. And if it's an enlargement, I should see that it got larger. 2, 6, 2, -2. Okay, I should see physically getting larger. Alright, then we talked about this. You're definitely going to see the translation between an image and a pre-image, the points, and then they want you to come up with the translation pattern in forms of x and y. Whenever we translate, we're always adding or subtracting to every x and y. This is just stuff that should be in your folder. So to do that, I have to determine the pattern between the points. So I look at -9, it changed to -6. They added 3 to make that happen. I look at 12, it changed to 2, they subtracted 10 to make that happen. So our point here would be, our rule, would be x plus 3 and y minus 10. And I think most of you already had that. So if you needed to check your f point, your f prime point, that was 3, -13. And g prime is -2, -3. Alright, so not everyone got their second page done. So what I'm going to be checking for, or holding you accountable for, is that you do on your test, they'll tell you to graph your pre-image, so you'll start with your original point. So we got 2, 4, 4, 4, 3, 2. Okay, this is J, K, P. And then they want us to dilate it with the scale factor of 2. So I will also be checking if you can give me the order pair. So we should have 4, 8. Then we had 8, 8. And P was 6, 4. So basically, we say justify your answer with work or show your work. Show your answer. And the way we check for that, let me fix my, see if it's going to let me fix my graph a little bit, yeah. That's better, sorry. The way we check for that is your graph matches your points. Matches what's supposed to happen in the problem. So since this is scale factor 2 is greater than 1 and it's an enlargement, then we should physically see an enlargement. And then 8, 8. And 6, 4. Alright, so we should see the triangle J prime, K prime, P prime getting bigger, and it does. Alright, and then on this one, because it's a scale factor of 1/2, that means we're going to multiply everything by 1/2. So I'm going to say 1/2 times the -2, and 1/2 times 0. Well, anything times 0 is 0. And then we're going to check for the points. So I'm just going to write them above here. So check your points, and then we'll check the graphing. Let's see something real quick. I won't. Like this. Sorry about that. Alright, so our points here were E prime was -1, 0, G prime 0, 1, and F prime 1, -1. And we should see basically a reduction. We start off with our original points, -2, 0, 0, 2, 2, -2. So here is our original triangle, and then our reduction as such. And we can see that the triangle physically got smaller. Alright, thank you about that one. Alright, let's talk about this real quick because I had some people kind of get stuck on this and the lines of reflection. Alright, we got to remember that a line of reflection is where you can map to itself. Let me pause this real quick and show you a little example of that. Alright guys, check this out. Hopefully this will help you have a better understanding what line symmetry is.
A shape has line symmetry when one half of it is the mirror image of the other half. The fold line, or mirror line, is called the line of symmetry. The line may appear vertically, horizontally, or diagonally. Shapes may have multiple lines of symmetry or no lines of symmetry. Not every figure has line symmetry. Symmetry is found in the world around us in nature, architecture, and art.
Alright, I think that's good enough. I think you kind of got the gist of it. So, on our review, they wanted you to state if it was reflectional symmetry, basically the line, rotational symmetry. Rotational symmetry is when you can turn it and it has to be less than 360 degrees and you still map onto itself. And then point symmetry, it equals 180 degrees. Okay, and I think I have some examples up here to help that, make you see that better. So this one, I think most of y'all saw that had line symmetry, just one line symmetry. And if I kind of just show, let me see, I know it's up here. Oops. If I show, there it is. We'll bring these up. So if I want to check rotational symmetry, basically I want to turn it. If I turn right now, that's 180 degrees. It's still not what we originally started with. And so I have to keep turning all the way around to a total of 360 for it to get back to the beginning, to itself. So it has to be less than 360 for it to be rotational. So this was no rotational. And guys, if it's no rotational, then it's going to also be no point symmetry. Because point symmetry means it only, it'll have a rotational symmetry of 180. So that didn't work. All right, and then on this next example, and I forgot to draw the lines, and thank you for Amari to correcting us on seeing it. We had a line of reflection there. Because this is a regular pentagon, meaning all sides are congruent because they're all 6, then I basically, when I come down from the vertice to the side, it's cutting that side in half. So it's going to be even as well, 3, 3. So with that being known that that's going to happen to every side, I could go from any point to the side, and that would be reflectional symmetry. Any point to the side, cut that side in half. Any point to the side. Can repeat that. And then you see that this would have 5 lines of symmetry. Now, to check for rotational symmetry, I'm trying to figure out what's the degrees I can turn it and it still be itself. Okay, so I know it doesn't look to scale, but since it's all 6, 6, I could turn it so that it still be itself. And we're trying to figure out that degree. So let's think about that, all right? So we know that there are 5 corners. So if I take that 360 and divide it by 5, what would my rotational symmetry be? 72. Okay. So let's think about it. If I were to have this center and turn that, oops, that was gonna happen. Let me get this part right. Turn that 72 degrees, basically go to another vertice and try to keep it in its center, which will be right such. I'm back to my original. See, it's still the same. Still the same. There we go. All right, so wanted you to be able to see that. So we have 72, and if it has rotational, then it's going to have point. So this was yes for rotational, and I'm going to abbreviate that, and yes for point. All right, so on this last one, on these next 2, this had only 2 lines of symmetry. When I think about rotational, the only way I could spin this, and I probably should have made a copy of that, is 180 degrees. So this was yes for rotational, and it was also yes for point. And I'm hoping you see a pattern. If it's yes for rotational, it's yes for point. And this was no for all. None of them work. Okay? All right, so I'm hoping that helps you understand that a little bit. You're definitely going to see those pictures with some answer choices with it. All right. So here, let's get the answers in there. I know some of you probably wanted just the key, so I'm going to put the answers down. And my only fear is that you just worry about the answers and not worry about how to get the answer. If you have a different answer than what I have up here, then you need to make sure you watch my explanation for that. So on 13, because we're doing a translation, this was 2, -3. Sorry, -2. Negative. No, it was 2. Because it was x minus 2. Sorry. 2, -3. Then we had 9, 5. Then we had -9, 5. And then we had 6, 4. And then you let me know if doing it this way works. I'm going to stop right there. This one was 6, -6, -4, or one at a time explanation. All right, this is a capital T. Capital T is for translation. And because I see -2, 3, that means this is going to be x minus 2, y plus 3. And that means that I'm going to do that to each point. Well, since my x is 4, this would be 4 minus 2. Since my y is 6, That'll be negative 6 plus 3. And then I simplified, that's why I got 2, negative 3. And then here we have a R for reflection, the x-axis. Whenever reflecting the x, you had a rule in your photable, and that rule was basically x negative y, which means the x stays, the y changes. I might not write them for all of them. So here again, we had 9 was my x, y was my negative 5 was my y. That's why we changed the y. It was already negative, so we changed it to a positive. 9, negative 5. And then when it's for the y-axis, the rule is negative x, comma y. So now basically we have the y stays and the x changes. Y stays and the x changes. Then we have our rotations here. We had rotation, this R 90 degrees about the origin. O is your origin, that just means your origin. So that just means 0, 0. This is what we've always done, so don't let that confuse you. And whenever I'm rotating about the origin, the rule for rotation for 90 degrees is negative y, comma x, which basically means we're going to change the sign of y then switch. I ran out of room. I apologize. The x and y. Alright, this is on your foldable. So here's 4 is x, negative 6 is y. We're going to change it to a positive 6, and we're going to switch the order, so it goes 6, comma 4. Alright, the rule for rotation for 180 is negative x, comma negative y. So we're just changing the signs to both x and y. So positive 4 now becomes negative 4, negative 6 now becomes positive 6. And then for 270, we have y, comma negative x. So this is when we change the sign of x. And then switch x and y. And then we've seen plenty of these. Capital D, that would be for dilation. So if I see D3, that's the dilation of 3 as the scale factor. That's what we're multiplying by. Okay, so we're multiplying each term, each value for the coordinate by 3. So this was negative 6, 9, and then this D1 half, we're taking a half of each point, a half of 4, and a half of 8. Half of 4, half times 4 would give me a negative 2, because that 4 was negative, sorry, and 4. Alright, so there is applying the rules. So then we have, on the next page, they want you to give the reflection of the image, of our pre-image, which is this triangle, over the x-axis and then the y-axis. Now, since it's the x-axis, let's see something real quick. Ew. Alright, so this is the x-axis and the y-axis. There's two things you need to know. Reflection has equal distance. So let's say if you didn't remember the rule, you can just physically count. This is 1 unit up. So we're going to do 1 unit down. And that would give me f prime as such. Then this is 1 unit below, so I'm going to go 1 unit up. So that is e prime. This is 1, 2, 3, 4 units down. So now I got 4 units up. 1, 2, 3, 4. There's d prime. And we connect it, and it sees that it crossed the x-axis. And then we just read those order pairs. But the rule basically says you're going to, for x, keep x stays, y change. So this was 1, 4, 4, 1, negative 1, negative 1. Now over the y-axis, we can do the same thing. We can just count from the y. So If I go over the y-axis, and I'm going to go ahead and just erase this so you can see the two different ones. This is, f is 1 unit to the left, so now I'm going to go 1 unit to the right for f prime. And then d is 1 unit to the right, so I'm going to go 1 unit to the left for d prime. E is 1, 2, 3, 4 units to the right, so now I'm going to go 4 to the left for e prime. And now I'm going to connect those, and now I have my reflection over the y-axis. You should have had negative 1, negative 4, negative 4, negative 1, 1, comma 1. Okay? So just check that. And then you had on this same page, just applying again rotations, just using your rule. We're going to keep, this is our pre-image, our original points. And we're just going to apply these points to 90 degree, 180, 270. And then you're going to graph them. I'm just going to make sure you have your table. So for 90 degrees, the rule is you change your y, and then you switch x and y. So basically negative y, x. So here we should have 2, 1. Y right here on E is already negative 4. We change it, it becomes a positive. So this becomes 4, 1. Here it's already negative, becomes a positive. This becomes 3, 4 because we got to switch them. The rule for 180 is negative x, negative y. We're switching both terms, x and y. So we have 1, negative 2. 1 now becomes a negative 1. Negative 2 now becomes a positive 2. And we just do that for each one. So we have 1, comma, negative 1, 4. And then we have negative 4, comma 3. And then our rule for 270 is y, comma, negative x. And we're going to change the rule. Change the x, and then switch the order of x and y. Change the sign of x and then switch the order of x and y. So we should have negative 2, negative 1, negative 4, negative 1, negative 3, negative 4. And then on 19, here they want us to translate. It says it here. Figure given the vertices function notation provided, and graph the pre-image and image. So we got to graph. They've already given us our pre-image with LMN. So we have 3, 2, and then we have M was 1, negative 3, and N is negative 2, negative 2. So there is our pre-image. And then we are going to use the following rule, T, negative 2, comma 3. That means we're basically translating, T is for translating, or translation, x minus 2, y plus 3. Alright, so we're just going to do that for every x coordinate and every y coordinate. And we should have here 1, 5, negative 1, 0, 0, 1. So check your work. Check that you can get to that point. Basically all I did was, I know my x is 3, so this is 3 minus 2. I know my y is 2. That would be 2 plus 3. And that's how I got to that point. We did that for every point. And then I want you to graph that. So I'm going to check that you have your graph and 0. Wait a minute. I must have graphed it wrong. Oh, I graphed this point's wrong. Sorry about that, guys. Alright, because it's a negative 2 minus 2, so that's a negative 4. And a negative 2 plus 3 is 1, so negative 4, 1. And there we have it, and it did. It looked like it went to the left 2 and then up 3. Alright, we're good. Oh, let's talk about this last one here. Well, yeah. You're definitely going to see a problem like this. I know the graph wasn't given to you. So to help you see this and understand it, you need to draw your own graph. The blocks of the sea is laid on a grid. Think of your grid like a coordinate plane. We're going to start at the origin, 0, 0. Since you walk 2 blocks to the north, so that means I went up 2, and then 4 blocks west, so that means to the left 4. And they want to know after, that's to the restaurant. So the restaurant right now is at, is at the point negative 4, 2, okay? After you eat, you walk 8 blocks east and then 5 blocks south. State the final ending point and the translation in function notation form. Alright, so that means now I'm done eating. I'm now going to go 8 blocks east. That's to the right. That's 4, then another 4. That's a total of 8 blocks. And then we're going to do 5 blocks south. So that's down. That's 2, then 3 more. That's a total of 5. Where will we end up? They basically want to know that coordinate, that point. And we should see that that is going to be 4, -3. Then they want the rule to get from the restaurant to that point. Translation form. Well, since I'm going to the right, that's positive, +8. And then when I'm going down, it's negative, -5. And that's the full rule. All right, and then on this last part, you need to do this in your own words. This will help you study. But basically, function or notation is using the parentheses. Okay, so if I'm doing a translation, on your foldable we have like x plus k and y plus h, or capital T, and then we have the value for x and then the value for y. Okay, either one of those are acceptable. But put in your own words what you have to do for a translation. And I'm hoping you know that's going to mean you're going to have to add or subtract. So just do this, guys. Read it off your foldable to every x and y. I don't think I need to kind of explain this. What I'm going to do is just kind of pause this video and get the answers up here. Or no, better yet, you can fill this in. I think you can do this. The only one I really want to talk about is there's a little typo, and that is with your dilations. So the scale factor of n is greater than 1. Okay, this should have been the scale factor is when it's greater than, it's a greater than n, it should be greater than 1. And then this should be when it's less than 1. And it really should be when it's less than, it's between 1 and 0. So there's a typo there. If I want to show dilation when it's greater than 1, and let's say n is the number that's greater than 1, then that should be n times x and n times y, which is going to be the same for a reduction. Okay, you just got to know when it's an enlargement and when it's a reduction. And when it's equal to n, that means basically this should have been n is equal to 1. Then you have, when it's equal to 1, you have just x and y. Basically, this is a congruency. It's congruent, and there's no size change. You have the exact same figure, okay? And then don't forget this part, your practice test, that's your extra credit. I'm not going to go over that. You need to try to do it, do your best. If you want to know to see how many you got right or wrong, you can come see me in the morning. Thank you for taking care of this. Make sure you study. I think I put some flashcards and an interactive kind of check where you just click on the link and you can do some practice problems and they'll tell you if you got it right or wrong. And it's a good way to get you prepared for your test. Happy studying.